Okay, what is chemistry and why are we here? So, if we're looking at the big idea of what is chemistry, we're going to see chemistry is the study of matter and the changes it undergoes. And that's going to lead us throughout this year, is that we're looking at matter and then how it changes for it. So, what is matter then? Well, if we're talking about matter, we're going to see that if it's not a technical definition, it's just stuff. And I really like that word because when we think of stuff, we think of things for it. But if we talk about its technical definition, it's anything that has mass and takes up space. So let's break down, what does it mean for something to have mass and what does it mean for something to take up space? Well, if we first look at mass, we're going to see that it's a measurement of the amount of matter that an object contains. Now, our SI or international units, we're going to see that it's represented as kilograms or kg, but in lab, we're just going to use G. Now, that's more practical when we're doing our labs, is that we're just going to be measuring in grams or a smaller amount than kilograms. Now, when we talk about mass, it's different than weight. So mass is going to be measured just for what we have for it, whereas pounds, we're going to see that pounds is relative to the gravitational pull, and that's why you would weigh different on the moon, which has less gravity or no gravity, versus if we look at our weight on Earth, which would be different because of that pull. So when we're talking about mass, that's how we'll refer to it in lab. If we say we need to mass out something or what is the mass, we're talking about grams for it. Now, are there any other units you can think of that we use to measure mass? So, we already talked about that we could use pounds. We can see in the kitchen, a lot of times we see ounces, or if we're across the pond, you might even see that they measure their masses in stones, meaning that for every one stone, that's 14 pounds. Now, that's a conversion, especially if you're like, oh, it weighs 5 stones, and then you have to do 5 times 14 and figure out how many pounds it is for it. Now, mass is how much matter it is, volume is going to be how much space it takes up. So it's the measure of space occupied by a sample of matter. Now, the international unit or the SI unit is meters cubed, and we'll see that that just means that they're using the volume formula of length times width times height. Now, in lab, we'll actually use milliliters, which is ml, because it's more practical. Because in chemistry, we're going to have a wet lab, so we're going to be using different glassware to measure out this milliliters. So, like you see here, if we're looking at volume, it's length times width times height, and that's how we have our meters cubed. We might even see centimeters cubed, and then we have our milliliters in our glassware. So, can you think of any other units to use for volume? We might see that it's liters. If we're in the kitchen, we might measure stuff in cups. We might measure it in tablespoons or even teaspoons for it. Now, you'll see that our units are a little bit different because we don't use the international metric system, whereas other countries do. So, if you go across the pond or Europe or other metric countries, you'll see that their gasoline is in liters, while ours is in gallons for it. So that's just a different measure for volume for it. So, right now, take a moment. You might even want to pause the video and ask yourself, is it matter? So, remember, to be matter, it has to have mass and it has to have volume for it. So, you might want to pause it before we go through it. So, welcome back. Hopefully you paused it. We're going to see that a desk is, yes, it is matter. It has mass and has volume. What about light? We're going to say that no, that's not matter. We're going to see that light is a form of energy, meaning it doesn't have mass or volume. Do you matter? Yes, you do matter, and you're also matter for it. Then we have air. So air is a tricky one. If you bring your hand up, don't hit your face. You can feel air hitting you. By feeling that, you can see that it does have mass and volume. Now, they're insignificant, but if you blow up a balloon, that's air. It's taking up mass and volume for it. What about love, the feeling of love? We're going to see that no, it doesn't have mass or volume, but it does matter in a sense. Okay, next we have atoms. They might be the smallest repeating particle, so that's a yes. And then water, we're going to see, is H2O. we'll see that water is also, yes, it has mass and it has volume. What about electricity? Oh, that's going to be a no for electricity. And then bacteria from biology last year, we'll see that, yes, it has mass and volume. And then our final one, sound. Sound will be a no, it does not have mass or volume. So, with that, chemistry is actually broken down into three different parts. And these three parts are going to lead us through our lessons. Now, our first part, we're going to start with atoms. So, part number one is atoms. We're going to start on our atomic level and then we're going to keep building up until we get to part number two in marking period number two, which means that we're going to be looking at bonding, how these atoms come together. We're going to look at our covalent, our ionic, our metallic bonds. And in our final part, part number three, is the part that you're going to love. It's rearranging these atoms in the form of chemical reactions. So that takes us through our three major units of study for chemistry. So remember, what is chemistry? It is the changes that matter undergoes. What is matter? Anything that has mass or volume. So thanks for watching this introductory lesson into what is chemistry, what is matter. Have a great day.